Hello and good evening and welcome to this tutorial on the Border Gateway Protocol Best Path Selection Algorithm. This is actually going to be part one in what is ultimately going to turn into a 13-part series where we're going to be taking a look at all 13 criteria on how BGP selects the best path. We're going to be taking a look at each of these individually, and I'm going to be doing a number of demonstrations kind of trying to show an exhaustive look at how you can manipulate each of these different attributes. And when we look at the first selection criteria, the weight, we're talking about not really a BGP path attribute, we're talking about a Cisco-specific parameter. And I want to make sure I'm clear on that because weight is a Cisco-proprietary, Cisco-specific parameter that is local to the router on which it's configured. In other words, it's not communicated to other routers, either iBGP peers or eBGP peers. And you'll see, and we'll actually prove this by taking a look at a Wireshark packet capture. When we see the BGP update messages coming in to router 5, you're going to find out that in the update packet, there is no field to communicate weight. We're going to see that you've got the next hop, the AS path, the origin, all of your well-known mandatory attributes. You'll see the MED, you'll see the local preference, but you're not going to see weight, and that's because weight is not directly communicated. Now, you notice I said directly. We're going to take a look at one sort of a corner case where weight may cause some unexpected results, specifically with a route reflector setup. So let's go ahead and jump in. Now let's take a look at the weight and see what the weight is going to do for us by taking a look at our topology. So this is our topology, and as you can see, we're going to be looking at this from the point of view of router 5. So as you can see, router 5 has an outbound path here and an outbound path here, and that is what the weight attribute is all about. It's about influencing the outbound flow of traffic. B-O-U-N-D, outbound flow of traffic, right? Weight doesn't play into the inbound flow of traffic. It's going to influence our outbound flow of traffic. So by default, the weight on a locally originated prefix will be 32768. And we'll see this here in a second with a number of our loopback addresses that we've locally originated. The values can go anywhere from 0 to 65,535. And again, this is a Cisco proprietary, Cisco specific, and it is not well-known mandatory, well-known discretionary. It's not optional transitive, optional non-transitive. It's none of those, right? It is a Cisco specific parameter that we're going to set. So let's go ahead, let's hop onto router 5 and let's take a look and see what we've got set up now. And we're going to force our traffic using the weight attribute to go outbound in a specific direction. And so really what we're going to do is we're going to change it from whatever the direction currently is on router 5. And let's see what that looks like. So let's go from user exec to privilege exec. And I'm going to say show BGP IPv4. I'll use both the old and sort of the new syntax for BGP. So show BGP IPv4 unicast. If I hit enter here, let's take a look at the BGP Rib, and you can see here, this is what we're looking for, right? We've got the asterisk and the greater than sign. Remember, the asterisk means that it's a valid route, and that greater than sign means that it's best, because remember, BGP, by its nature, is going to select a single best route from all of the routes that it's receiving. And that's where that best path selection algorithm comes into play. So for the prefix 1.1.1.1, and this is being originated up in AS100, we can see that here in the AS path output, that it originated in AS100. And the difference is this right here. So that update for this prefix came through AS900, and this one came through AS400. So which one did BGP select? Exactly, it selected AS400. Let's take another look here. We've got the asterisk and the greater than sign here. And again, you can see the route coming through AS400 was selected as best. In fact, for all of the routes, with the exception of the loopback address here for router 9, because again, shorter AS path, but we'll get to that in a subsequent video, you can see that everything that we were receiving north of routers 4 and 9, that AS400 is going to be the preferred exit point. So if we go back to the diagram that we looked at previous, right, we see this diagram here. Right now, all traffic is preferring that as its exit point, going to AS400 as its exit point. So if we were to say that AS400 is AT&T, and we'll say that AS900, just for the sake of argument here, is level 3, right? The only prefix that router 5 prefers to go this way to get to is that 9.9.9.9, right? But that originated here in AS900, and it's got a shorter AS path. So let's go ahead. Let's influence all traffic using the weight value and take a look at the different ways that we can do it. We're going to take a look at the neighbor statement, which is pretty much the easiest way to do it, manipulating a neighbor statement. We're going to take a look at a prefix list with a route map. We're also going to do an AS path access list and then apply a filter list to the neighbor statement. So let's go ahead and do each of those in turn. And let me clear this off here. All right, so back to the command line, and we're on router 5 here. Let's force all of our traffic to take the path to AS900. So let's get into global config. We're going to say router BGP 567. That's our autonomous system number. We're going to say address family IPv4 unicast. And then we're going to go into, or actually let's say do show run section BGP. Let's see what we're dealing with here. All right, so we actually already have a statement here. Let's get that out of there. And we do not want that. And then let's go do clear IP BGP 192.168.55.7 soft in. All right, so we're just going to do a soft reconfiguration here for router 5 real quickly, because we had a stray weight statement there. So do show run section BGP. Let's take another look now. All right. So the weight statement is gone. So here's what we're going to do. We're going to prefer using the Cisco-proprietary parameter, right? Not a Cisco, or I should say, not a BGP Path Attribute, right? Not a BGP Path Attribute. It's a Cisco-proprietary parameter. And let's make that happen right now. So we're going to say neighbor 209.165.59.9, and I can simply put the weight value. Again, there you see it's 0 to 65,535. So let's put something demonstrative here. We'll say 55,555. So 55,555. I'm going to hit enter. We'll say end, and let's take a look. Has anything changed? What do you think? You think anything's changed? Let's take a look. Show IP, and we'll do it the old school way. So show IP, BGP, enter. And you can see that shows me the same thing as when I said show BGP IPv4 unicast. Let me get that V4 together there. IPv4 unicast. So show IP BGP or show BGP IPv4 unicast. And again, that new syntax is all about the address families, right? Okay, so now we take a look and we see that the results are the same. And take a look at the default weight, right? For a locally originated route, what is my default weight? You've got it. So we originated this with a network statement. You can also tell it's locally originated because we've got those quad zeros in the next hop field. But again, I locally originate a route, it's 32,768. But what is the default weight for everything I'm learning? Exactly, 0. So when we did that neighbor statement, I could have said neighbor 209.165.59.9 weight 1. I only have to be greater than what is showing here in order to manipulate that setting. But let's get back to why doesn't it show up here? So we made the change, but it doesn't show up. Well, remember that BGP, we need to reread the config. And so we can do that in a couple of ways. A quick note, if I say clear IP BGP star, we don't want to do that, and you especially don't want to do that in a production environment. That is going to reset. It'll definitely reread the config, and we're definitely going to see the change that we're looking for. But in addition to that, it's going to break or tear down all of the BGP neighbor relationships, both eBGP as well as iBGP, and we don't want that. So we want to say clear IP BGP, and I'm going to put the neighbor address in here because I'm going to do it to the specific neighbor 209.165.59.9, and we'll say soft inbound. Now, this is the key. When we go to do the filter list, and we go to do the IPAS path access list and the route map, what'll end up happening is we apply the route map in the inbound direction, right? And the reason for that is, again, we're setting it in the inbound direction because what we're saying is prefixes that I'm receiving from this neighbor or from this autonomous system or this specific prefix, when I receive them inbound is when I set the attribute so that it will affect and impact and influence the outbound flow of traffic. And so we'll see that here shortly. So I'm going to say clear IP BGP soft in. And you can see we've got some updates flowing by here, right? Send update, send update, send update, skip update. Well, let's go over to our packet capture real quickly here. And you can see here's an update message that just flowed by. And let's take a look at this update message here. And specifically what I want to look at are the path attributes. So right there. So if we take a look at these path attributes, what do you see? Well, we've got the origin, well-known mandatory. We've got the AS path, and you can see right here, here is the AS path, 900, 300, 100. Well-known mandatory. Next hop, well-known mandatory. Multi-exit discriminator, typically you'll hear it just referred to as the MED. This is optional, non-transitive, which means it's not going to go further than one AS. And then we've got the other, and this is, I shouldn't say the other, we have the BGP Path Attribute that is similar to the weight, and local preference is going to affect the outbound flow of traffic as well. And that's actually going to be our next video. But what I'm trying to drive home here is you take a look at this, origin, AS path, next hop, multi-exit discriminator, MED, local preference. Where is the weight? Do you see a path attribute for weight? And the answer is no, you don't, because weight is not a path attribute. And again, I'll even go down here further, right? You're not going to see weight listed as a path attribute because there is no field in the update message to communicate weight. It is locally significant. It is not directly communicated with any other BGP neighbor, either iBGP for interior BGP or eBGP for external BGP, or I should say internal BGP, external BGP, right? So it's not communicated at all. So now let's come back to router 5 and let's take a look at that show IP BGP, which we could have also said show BGP IPv4 unicast, right? If we're dealing with address families. And what do you see immediately that's different? Well, again, we made it pretty demonstrative over here when we said we're going to set the weight for all prefixes that we are learning from that neighbor right there. We are going to set the weight to 55555. And did it work? It absolutely worked. Take a look at that, right? So for these prefixes, for the 9.9.9.9, for the, where's the next one? The 4.4.4.4, which is the loopback address from AS400 router 4. 3.3.3.3, which is a loopback address in AS300 on router 3, and 1.1.1.1, which is the loopback address for router 1 and AS 100. And now what is the best, or I should say the valid with the asterisk and the best with the greater than sign, what has been selected? All of these are now going to go out to router 9 as the next hop. In fact, let's kick off a trace route here and see what that looks like. So I'm going to go ahead and say trace over to 1.1.1.1, and we're going to source it from our loopback 5.5.5.5. And where's my first hop? You've got it. That first hop is going to be 209.165.59.9. What if I were to change the 1.1.1.1? Let's make sure here and say 3.3.3.3. And we still go out router 9. What about 4.4.4.4? Now this is interesting because remember, if we scoot back up here and we take a look, the valid and best to get to, and this shows you that the weight supersedes all other BGP best path selection algorithm choices, because we have this other path here right below it that literally we are directly connected to that router that is advertising this loopback address. But is that the best path through router 4? No, it's not. There's no greater than sign here. I'm saying that the best path is through router 9 because I have set the weight. Take a look at that. The AS path value, or I'm sorry, the AS path there's one AS path. We are literally directly connected to that autonomous system 400. Here we've got to go through 900 and then 300 and then over to 400 when we could have gotten there in a single hop, right? But again, we've set the weight, and weight trumps every other BGP best path selection algorithm criteria. So let's run that trace real quick and let's see. Does it do what we think it's... Oops, sorry about that. I was going to say trace. I forgot to put in the 4.4.4.4. So let's get that in there. And where does it go? It goes to 9, to 3, to 4. It does exactly what we told it to do, because what we're saying is all of the prefixes that we learn from neighbor 209.165.59.9, and again, that is going to be anything coming from this neighbor right here, AS900, all of the prefixes that AS is passing along to router 5, we are setting the weight and saying that for outbound traffic, for all prefixes learned from AS900, we want to go this direction, right? Now, this will still be a viable path if for whatever reason this went away, right? This would then come online, and let's take a look at that. Does that actually do what we think it's going to do? So let's go into serial 010. I'm going to global config interface serial 010 and say shut. And you can see we've got all kinds of BGP information going. We've got one of my debugging the updates, as well as inbound for IPv4 for BGP. So now let's go ahead and say show IP BGP. And who is my best path now? So as you can see, right, I mean, this is sort of an auto magic way to go ahead and set it up and say, I'm going to prefer all of my primary communications to go to level 3. If my connection with level 3 goes down, then auto-magically, as you saw right here, what just happened, router 5 is simply going to go ahead and say, okay, great. We're going to go ahead and use AT&T is now going to be my primary path. But what happens if we bring up that connection again, serial 010, and say no shut? So that connection is going to come back up, and BGP is not the fastest converging protocol out there by any means. So show IP BGP, what do we see? Do we have everything back in there? And we already do. That was actually pretty quick, right? But again, we're not taking in a full feed of 600,000 internet routes. We're taking in about 6 routes. So went pretty quick, and we've got the primary path back. So automatically that primary path comes back, our traffic flow goes back over. And again, this is all being done by using WEIGHT. So show run section BGP. And again, that's it. It's a single command. Now, let's say that we don't want to use the neighbor command because as you saw for AS400 for the loop back there, we're kind of taking the long way. We're going from 9 to 3 to 4 instead of going directly to 4. So, using the neighbor WEIGHT statement is phenomenal in this use case right here when we simply say everything go out to the left, and if the left path fails, go into level 3, everything go to the right. Now, let's take a look at the next way to manipulate the WEIGHT. And we're going to do it with an, we'll do it with a, what am I trying to say here? With an AS path access list. So I could basically say, instead of setting the neighbor statement to set the WEIGHT here, I could do an IP AS path access list. But let's say that we just want to manipulate that, or we'll say all routes originating from AS100. So for everything coming out of AS100, I want it to go this way, right? I want 1.1.1.1. I don't want it to go that way, right? We don't want that. We're going to send it all to AS400. So let's jump in and let's do that from the command line. So let's come back over here. And so the first thing we're going to do with an IP AS path access list is we're going to create the IP AS path access list. So we simply say IP AS path access list, and we can number it, right? 1 through 500. I'll just simply say 1. And now we're going to use a regular expression. And actually, before we do that, let's do this. If I were to say do show IP BGP, you see we've got the output here. If I wanted to see all prefixes that have originated from AS100, I could say _100 $. And that's a regular expression. The underscore means that there may or may not be another path on the left-hand side of 100, but that on the right-hand side, we should only see, I forgot to put the regex in there. There we go. So we're only going to see routes that have originated, right? You see this reading from left to right, the rightmost value in the AS path, that is the originating AS. And as you can see, there's only one route. And take a look. Where is that route? Or that, I should say prefix. I keep saying route. Where is that prefix currently looking or going on the outbound direction? It's going out through router 9 or AS900. So we're going to fix that. So we're going to say IP AS path access list 1 permit. And then I'm going to say _100, whoops, $. So all prefixes that I'm learning that are originating from AS path, or I should say from Autonomous System 100, we're going to manipulate those and we're going to set the WEIGHT to be higher. All right. So we've got the AS path access list. So now what we need to do is we can go ahead and we can do a route map. So I can simply say, whoops, we'll say route map, and I'll just call this AS100 and permit 10. And let's go ahead and say match AS path, and we used 1, and we're going to set the WEIGHT, and I'll set the WEIGHT here to 65432, right? Because that's definitely higher than the 55555. All right, so now let's go into router BGP 567. We're going to go into address family IPv4 unicast, and here's what we can do. Do show run section BGP is I can actually set this on router 4, because remember, it's going to be local to this router. So let's see, is that going to be enough? So if I were to say neighbor 209.165.45.4 and then say, whoops, route dash map, and what do we say? AS100 was the name. Now, what direction are we going to set this? Again, remember, I'm setting it on prefixes that are being learned in the inbound direction so as to influence the outbound flow of traffic. So I set it on the route of the prefixes as I'm learning them, so that way when I go to send traffic to those prefixes, BGP makes that selection for the outbound direction. So let's go ahead and say clear IP BGP, and we'll say 209.165.45.4 soft in. All right, so we're going to see that that gets changed there. And now let's take a look. Show BGP IPv4 unicast. And what do you think we're going to see for the 1.1.1.1? And take a look at that. So now we've got quite a choice of weight settings over there. So the valid and best for the 1.1.1.1 is no longer the path through AS900, router 9. The best path, right, because of that greater than sign there, the best path is now through AS400 through router 4 because we have a higher weight value. And so that's one way that you could manipulate individual prefixes. Probably better to say where you could manipulate the prefixes being learned from a specific autonomous system using an AS path access list. All right, so let's go ahead and do one more. Because again, we've already seen how this, right, that doesn't make much sense. We've got this prefix that we're learning it from router 4 and router 9. We're selecting router to go through AS900 because it's got a higher weight. However, we are directly connected, and I didn't mean to include the 0 there. We're directly connected to AS400. So it probably doesn't make sense to go to 900 and then to 300 and then to AS400 to get to that destination. So let's go ahead. We're going to set the weight one last time. We've done it now two different ways. We set it on the neighbor, saying everything we're learning from this neighbor. We did an IP AS path access list to say all prefixes learned from this specific autonomous system. And now what we're going to say is this individual prefix I want to manipulate. So let's go ahead here and, let's sort this out. So we're going to say router BGP 567, address family IPv4 unicast, do show run section BGP. And then we're going to say no. I'm going to pull off the access list, the route map that we created just a few seconds ago. And then we're going to do a new one, but we're going to do this one based off the prefix list. So we'll pick off the prefix 4.4.4.4. So I'll get one more out of here, get to global config. So IP prefix list, and we'll say LO4 loopback 4 sequence number. I like to start with 5, permit, and sorry about that, permit 4.4.4.4/32. All right, so now we need a route map that's going to call that prefix list. So we're going to say route map, and we'll just call it LO4 as well for loopback 4. Permit and 10. And then we are going to match, So we're going to say match IP address. Now, key here, remember, we're using a prefix list, not an ACL. So I've got to say address prefix list, then I put down the name of the prefix list. Loopback 4. So if I match what that prefix list is going to match, what do I want to do? Well, very similar to that IP AS path access list, I'm going to set it to 65.534. Set the weight to 65.534. So let's get back into that router BGP 567, address family IPv4 unicast, and then do show run section BGP. Let's make sure we've got a good setup here. And we do, and so now what we're going to say is neighbor 209.165. And we're learning this from both neighbors. I'll even go ahead and we're going to set this on 4. So 45.4 and route map LO4. And again, we set it in the inbound direction. So let's do one more look here. Show BGP IPv4 unicast. And 4.4.4.4, the valid and best path is through where? It's through AS900. It's through router 9. And why is that? Because the number one criteria in the BGP best path selection algorithm is the Cisco proprietary parameter, not the Cisco, not a BGP best, or I should say, not a BGP. And now I'm trying to complete blank. Again, it's a Cisco proprietary parameter. It is not a BGP path attribute. Okay, it's not a path attribute. It is a Cisco proprietary parameter weight, right? In this column right here. That's a path attribute. This is a path attribute. That's a path attribute. This is a path attribute. This is not a path attribute. It is a Cisco proprietary parameter. Just want to keep driving that home. So you can see it's set to 55.555, and that's what's telling it to go to AS900, then to 300, then to 400. We're about to upset the apple cart and fix that by saying prefix 4.4.4.4/32 should be going directly over to AS400. So clear IP BGP 209.165.45.4 soft inbound, and we should see some activity here. We do. And now let's take a look here. So show IP BGP the old school way. And what happened? Did we get the expected result, or did something else go wrong? Exactly. Take a look. If you notice that something else is missing here, you're right. All the other paths that were learned here. Because what happened? It's in the route map. Think about it. Exactly. At the end of the route map, there's an implicit deny all. So we'll fix that here in 2 seconds. But let's take a look at our prefix now. So here's that 4.4.4.4. And did it work? It certainly did. That is now my best path because that is a higher weight. So now let's sort out the route map real quickly here. And if we take a look at the route map, if I were to say show route map, oops, LO4. So there it is. We've only got one clause, and that's sequence 10. So let's add in another one here to permit everything else, because you'll notice we're not, oops, sorry about that. Let's try to settle this down. We're only learning a single prefix through AS400 now. You see that here? Everything else is being learned from AS900. And the reason is the route map at the end, what I forgot to put in there was route map LO4 permit, and this is going to be 20, and then just simply end. And that's it. I'm just going to leave a blank statement in there because that's going to permit everything else. And so let's go ahead. Let's run that clear again. So clear IP BGP 209.165.45.4. What do we say? Soft in. All right. So we should see some activity here. And we're not seeing any activity. Clear IP BGP 209.165.45. Okay, there we go. It took it a second there. All right, so now let's go ahead and say show BGP IPv4 unicast, sort of the new school, and there we go. So all of our routes are back now. So we had left out that statement in the route map. But again, even with the route map fixed, take a look. Because the weight setting on this prefix and this prefix alone is higher than every other weight setting, we fixed it, so to speak, so that instead of going from AS567 to 900 to 300 and then to 400, we go from AS567 directly to AS400, right? So this is certainly one way we can deal with the problem. And again, the reason it makes sense is because we only have a single router as our edge router, and it's multi-homed, right? When we talk about local preference, you'll see what happens when we have two routers from this autonomous system that are each connected to different service providers. So dual edge, multi-homed, right? Or I should say dual edge, dual homed. autonomous system setup. So now let's take a look. The final thing we're going to do is we're going to take a look at this corner case when router 5, which router 5 is a route reflector, we're going to see what happens here. And I'll iconify that, and let's pull up that drawing right there. So what happens when we get rid of this connection from router 5 to AS400? And so now we have a second router in AS567 that's connected directly to AS400. So there's an eBGP peering here, obviously. We've got an eBGP peering here, but then router 5 is a route reflector, and router 6 and 7 are route reflector clients. So let's clean our config up real quick and then take a look at this, and then we'll wrap things up. So let's go into global config, router, BGP 567, address family IPv4 unicast, and do show run section. Come back here, run section BGP. So we're going to say no. And then we're also going to get rid of the route map on router 4 inbound, copy and paste. And so there we go. And you can clearly see here, right? Routers 6 and 7, they're route reflector clients. So we're gonna fix that. We're gonna interface serial 000. Do show IP interface brief. Let's make sure that's our interface to router 4. It is, and we're gonna say shut. And then we're gonna say in clear IP BGP 209.165.59.9 soft inbound. And we're going to reset that. And now on router 7, let's go ahead and bring up that connection. Show IP interface brief for that eBGP peering out serial 0. Interface serial 010. And we're going to say no shut. Save our config there. So this is going to bring up that eBGP peering. And then we're going to see what happens over here on router 5. So say show IP BGP, and you can see that, and there we go, we're getting some updates in here, and that's what we're looking for there. So let's talk about that show IP BGP 1.1.1.1/32, because now what we're going to see is we're going to see that router 5, who is the route reflector, and let me draw a line here underneath that, because we've got these two paths, right? So two paths are available. My best path is number 2. And when we're looking at this, the reason it's the best path is because it's external. And so this is number 2. So right now, if I was to trace to 1.1.1.1, we'd go 900, 300, and then hit the prefix in AS100. And my next hop is 209.165.59.9, which is router 9. So let's see, what does router 6 see? Because remember, router 6 is a route reflector client. So on router 6, if I say show IP BGP 1.1.1.1/32, you can see that we've got two paths on router 6 as well. Because router 7 is also sharing, and hold on one second there, you can see here from router 7, that last octet, and there's the BGP router ID, you can see that that's not the best path. The best path is coming from the route reflector, router 5. Because remember, router 5 is the route reflector. He is going to tell 6 and 7, here is the best path that I have selected. And then 6 and 7 make that same installation, right? Or they make they take that route and then they do their calculation on it to determine whether or not it's the best path. But on router 6, this is the best path. So given that 6 is going through 5 and up to 9, and you can see there's the next hop IP, right? So it's learning it from router 5. The next hop IP is 59.9, router 9. So 6 is going to go to 9, and 5 is going to go to 9. And so this is how we're going right now. 5 is going that way, 6 is going that way, right? But what if we said we want 6 to go this way and 5 to go that way, and 7 to go that way. So everybody goes out via router 7. So what would happen if I were to set the weight on router 5 and prefer, right, on updates I'm getting from router 7 to increase their weight? What would happen? Well, let's check it out. Let's see if we've got unintended consequences here in this sort of corner case route reflection setup. And so on router 5, and we're going to go ahead and we'll take the easy way out here. So we'll say router BGP 567 and address family IPv4 unicast. And I'm going to say neighbor 192.168.55.7 weight 65432. Right? So do show run section BGP. So what I've just done as the route reflector is I'm saying that all prefixes that I learn from router 7, that locally on router 5, I am going to ensure that my BGP best path selection algorithm looks at the number one criteria, which is the Cisco proprietary parameter weight, and I'm going to set the weight to 65432 on all prefixes I learn from router 7. So what is that going to do? Exactly. That's going to influence my outbound. And when I say outbound, out from my autonomous system 567, I'm influencing how we're going to exit on router 5. So let's go ahead and say clear IP BGP 192.168.55.7 soft in. So we're going to do a soft reconfiguration. You can see we've got all kinds of activity here. So let's take a look. Show IP BGP. We'll do the old school version. And when we take a look at the prefixes here, the valid and best is who? Now, don't be fooled here, right? So it's saying that the next hop is 209.165.47.4. But remember, we're not connected. We're no longer connected to AS400. Who is connected to AS400? Router 7. So we need to see a little bit more detail here. So we'll say show BGP IPv4 unicast for 1.1.1.1/32, right? We'll use the new school format for address families. And now we start to see what's happening here. So as the route reflector client, and let me change this back to red, I'm sorry, not the route reflector client, as the route reflector, right? Router 7 shared with me the prefix, shared with me an update to get to 1.1.1.1. And I set the weight on that to 65432. There it is right there. And weight is the number one. It's the first thing that's evaluated in the BGP best path selection algorithm. And again, if it's not, you don't see it listed here, it means it's the default of 0. So 65432, which means the route reflector, even though I received this route from a route reflector client, I'm setting the weight on it to be 65432, which is definitely going to make it the best and valid path that I am going to follow to get to the prefix 1.1.1.1.1. Now, here's the big question. Remember what we said. We said that weight is local, right? It's not communicated to other routers. So let's go over to router 6 and let's see if that is I'm going to say UAll. I believe we're debugging something here. Okay, so we've turned all debugging off. So now let's say show IP BGP. We'll use the old school 1.1.1.1/32. And what do we see here? Isn't this interesting? So, whereas before on router 6, we took a look at this earlier, remember? And what was my valid and best path? It was through my route reflector, router 5. But now that is no longer the case. What is the best path now? So I locally set the weight on router 5. Router 5, for all updates coming from router 7, sets the weight to 65432. Router 5 then makes his best path selection algorithm choices. Number 1 right out of the gate is weight. No question that all of the prefixes I've learned through Router 7, those are going to be my preferred best prefixes. And the route reflector is only going to communicate to his IBGP peers, or his route reflector clients. He's only going to communicate the best path. You'll notice there's no weight here, right? So technically, it's still a true statement that weight and the Cisco proprietary parameter weight is not communicated to other routers. Because again, there's no way to do it. There's no field in the update message to do that. But here is an unintended consequence of when setting the weight on the route reflector impacts the route reflector clients, because the route reflector is telling the clients, hey, I've taken a look at the prefixes that I've received. Here is the best one, and this is the one that we should be using, and that is where this came from. And that is why this was selected as the best, but you will never see the weight there. And this is where it can become very confusing if you're setting the weight, in a scenario, again, corner case scenario, but definitely something to keep in mind. That this is one of those unintended consequences when you look here and you say, well, wait a second. How could it possibly be selecting this as the best? Because the weight's not set. Right? I don't see a weight value here. And then you would have to go back through the best path selection algorithm, to see what may be going on. But you're never going to see the weight value listed there because it's not communicated. This route, again, was received as a result of the route reflector doing the calculation and then communicating to his clients, hey, this is the best path and this is how we should go. All right, well, that's pretty exhaustive. We took a look at a lot of stuff here. We took a look at the neighbor weight statement twice. We took a look at AS path access lists. We took a look at prefix lists and route maps. We talked about the default value of the weight, 32768, the 16-bit value that you could set the weight to, anything from 0 to 65535. We talked about how it's not in the update messages. It is not a BGP path attribute. It is simply a Cisco-specific parameter. All right, well, that is going to wrap up the first video in the 13-part series here, where we're going to be taking a look at each and every individual BGP best path selection algorithm criteria that's out there. I hope you enjoyed this. I hope you've got a better understanding of weight, how you would use it, when you might want to use it. Again, a lot of people call it a kludge, or kind of rigging it up. But again, in the scenario that we're talking about here, where we have a single edge router, and not that scenario there, but this scenario here, where you've got a single edge router that's multi-homed, theoretically you could use the weight. That's a very easy way to do it. It really wouldn't make sense to use local preference, because there aren't any other edge routers connected to a different service provider or another service provider that I would need to communicate that information to. We've got one guy, router 5, and that's it. All right, thanks so much for watching. Have a great night, and I'll see you in the next video on local preference.